In our final video for Chapter 8, we're going to be solving inequalities. And in fact, we can use the same approach that we use when solving equations. So if you remember something like this, x plus 5 equals 12, right? We can subtract 5 from both sides, knowing that as long as we do the same thing to both sides of an equation, they remain equal. So we can subtract 5 from both sides, and that gives us x equals 7. So if we want to solve an inequality, we can do the exact same thing. Just to show that this does work, let's look at an example. So I have here 3 is less than 5. Hopefully you all agree that it is true that 3 is less than 5. Now, if I were to add the same number to both sides, right? If I add 2 to both sides, I get 5 is less than 7. And that's still true. So as long as I add the same thing to both sides of an inequality, the inequality is still true. The same thing would be true if I subtract. If I subtract 1 from both sides, I get 2 is less than 4, and that's true. So as long as I subtract the same number from both sides of the inequality remains true. Same thing if I multiply, right? I could do 3 times 3 on both sides, and I would get 9 is less than 15, still true, and I could divide both sides by the same thing. Okay, now I didn't choose nice, easy numbers, so let's just real fast change this to 6, just to prove, right? If I divide both of these by 3, I get 1 is less than 2. So we can see that as long as I do the same thing to both sides of an inequality, the inequality remains true. So let's put this into practice. X minus 3 is greater than 1. So if I want to solve for x, once again, I need to isolate x. So right now I have x minus 3. I want to do the opposite of that. So I'm going to add 3 to both sides of the inequality, and I get x is greater than 4. Okay, now that makes sense, right? If I were to go back and look at this and substitute 4 for x, I would have 4 minus 3 is greater than 1. You'd get 1 is greater than 1, which that's not true. But what we see here is anything that's greater than 4 would be true, right? X has to be greater than 4. So if I were to use, for example, 5, I would have 5 minus 3 is greater than 1. And 2 is greater than 1, so that's true. If x were 7, I would have 7 minus 3 is greater than 1, and 4 is greater than 1. So as long as x is greater than 4, that's a solution to this inequality. Let's look at the next one. We have 15 is greater than or equal to 6 plus h. Okay, so again, I want to isolate h. Right now I'm adding 6 to it, so I want to do the opposite of adding 6, which is subtracting 6. So that leaves me with 9 is greater than or equal to h. Okay, so h needs to be greater than or equal to, 9 needs to be greater than or equal to h, meaning h needs to be less than or equal to 9. Let's look at another one. We have x divided by 5 is less than 2. So if I want to solve for x, right now it's being divided by 5, so I need to do the opposite of that, which is multiply by 5. So that would give me x is less than 10. So for any value where x is less than 10, this inequality is true. Okay, we've also got 4n is greater than or equal to 32. So right now, n is being multiplied by 4, and I want to do the opposite of that, which would be dividing by 4 on both sides. So that would give me n is greater than or equal to 8. Okay, so again, any value for n that's 8 or greater would be true for this inequality, because I know that 4 times 8 is 32, so 4 times anything larger than 8 would also be greater than 32. Finally, let's look at one with a fraction. So we have 2x divided by 3 is less than or equal to 4. So remember, when you see a fraction like this, right, we need to multiply by the reciprocal of that fraction if we want to isolate our variable. So right now, x is being multiplied by 2/3, and we can simply multiply by 3/2 to isolate our variable. That would leave us with x is less than or equal to 12 over 2, and that simplifies to 6.